Very good evening to all. I am Sanjana. Due to some personal issue, Vince Perlin sir cannot take today's sections, everyone. So it will be held on tomorrow. So yesterday we had a great and wonderful session by Mohit Tiwari sir. So we will continue with the advanced foundation model, AI genetic AI. So I would like to request Mohit sir to continue the session. And thank you so much, everyone. Actually, I have some cold, so I'm not well today. Thank you. I would like Mohit sir to start the session. Mohit sir?
Yes, I have joined, yes. So I was trying to speak, I didn't realize that I was on mute. Anyways, so it happens with everyone. Anyways, first of all, a very good evening and a nice warm welcome by Ms. Sanjana. Sanjana, get well soon. I hope you get well soon and recover quickly. So anyways, good evening everyone, and before we begin, let me briefly connect today's session with yesterday's discussion. I hope everyone had some good benefits and learning on my session yesterday. So yesterday we looked AI as a support tool, how it assists us in tasks like content creation, analysis and academic work. Today we will take a big step, the next logical step, by understanding how AI is evolving into agentic systems. Now agentic AI is the trending word today. Systems that can plan, that can decide, and who can act with a certain level of autonomy. So today's sessions builds directly on that foundation. Now here I would like to set the context very clearly. This session is not about replacing educators or researchers with AI. It is about understanding how AI systems work, where autonomy comes in, and how we can use such systems responsibly in education and research. The session will be structured and interactive. I will make it as interactive as possible. Just like yesterday, I will pause at some points for brief inputs. So I request you all to stay engaged. With that, let's begin by understanding the foundations of artificial intelligence. Just give me a moment to share my slides, and then we will start with the session. So can anyone please acknowledge if they are able to see the slides? Is everyone able to see the slides?
Yes, sir, it's visible, sir.
All right. Thanks a lot. Yeah. So, starting from the first part, which is the agentic AI. Now, what do you mean by an agentic AI? And before we begin, just type yes in the chat if you have already used any AI tool in your academic work. I would like anyone or few people who have just used any type of AI tool in your academic work. No issues. We will now move forward and we will see what this is and what this concept is all about. Now, first of all, again, a big welcome to this faculty development program. Today's session is designed to build conceptual clarity, not hype, especially around how AI is evolving into autonomous decision-making systems called agentic AI. Now the next, let's have a small introduction. This session will be focusing on how AI is moving beyond simple automation. AI today can perceive, reason, plan, and act in dynamic environments. For educators, this shift has direct implications for teaching, research, governance, and institutional systems. Now, what are the aim, relevance, and outcome is of this session and the program? The aim is to introduce the foundations of AI and the logic behind agentic systems. The relevance is very clear in India, particularly through India AI Mission, Centers of Excellence, and AI adoption in public systems, as you are all must be observing and seeing how AI has changed and revolutionized on how we work, how we research, and how all of us are enhancing our academic activities, research innovations, and curriculum modernization. By the end, we should all be able to understand how agentic AI works and where it fits responsibly in academics and industry. Before going on to agentic AI part, let's have a small brief on what actually is AI. So AI is the common buzzword everywhere. Now AI refers to the computational systems which are capable and which are designed to perform perception, reasoning, and decision making. Now it's not magic as few think that AI can do anything without a proper prompt or a proper design or the proper data. No, it's not. It's just that it is a simulation of the human cognitive abilities using data and algorithms. AI is the backbone of AI is data and algorithms which are used to give the desired results. Now in this diagram, you can see what actually are the various parts of artificial intelligence. The main key domains are machine learning, neural networks, NLP, which also is a very famous word these days, which is also known as natural language processing, which is nothing but the ability to understand what we are speaking and to understand and analyze the documents in the same way ChatGPT or any other Perplexity or Gemini does it. And the fourth part is the robotics part, where the machines that can assist the people which are without actual human involvement. So you can pause for a second and you can see these various domains and try and learn about these four domains which are the key domains of AI. So just try and visualize AI as an umbrella under which these technologies or these key domains actually operate. Now let's see a little bit about the evolution of AI. Now AI has evolved from rule-based systems to machine learning and now to autonomous agentic systems. So the growth of AI has been actually exploded in our country. If I'm talking about our country, India, everywhere everyone is doing these kinds of courses, these kinds of resources. Everyone is searching for these kinds of agentic AIs and all. So the evolution of AI is so actually the right word is actually is not evolutionized, it's actually exploded into the tech world. So the key shift is continuous learning and adaptation of AI. Now, every AI system is dependent on 4 pillars. The 4 pillars are data, algorithms, compute, and evaluation. Now, weakness in any one of these can lead to unreliable AI outcomes. So let us be all very clear that AI needs structured data, powerful algorithms, computing resources, and evaluation metrics. Now, each component has to be accurate. It has to be continuous improving, and just like in India, ISRO uses AI-based predictive models to support the navigation of satellites and mission control operations. Now, when we are talking about AI, the components of it, let's see the types of AI. There are 3 main types of AI, which are narrow, general, and super. AI is categorized by capability. Most systems today are narrow AI, which are designed for specific tasks. General and super AI remain more of theoretical. So they are actually based on capabilities. Task specific, narrow, human level is general, and surpassing even the human intelligence is super. The most real world systems belong to narrow AI, which are designed for specialized tasks and specific tasks. Like example, from India, Swiggy and Zomato, they use narrow AI to optimize the routes of their food delivery and demand predictions, on which route, say maybe we had done a small project on Zomato, and there we used a narrow AI to predict on which consumers are ordering which kinds of dishes in which area. So it was a small project on this. So it was a very good way of learning how narrow AI actually works. So this diagram shows it differentiates A and I, AGI, and ASI. Right? So artificial narrow intelligence is A and I, which is the stage 1, which is connected to machine learning, which is specialized in one area and solves one problem. Artificial general intelligence, which is AG, which is the stage 2 part, where machine learning and artificial intelligence are connected, which refers to a computer that is as smart as a human. I would request to be kindly on mute, please. I would request, sir, kindly mute yourself, please.
Hello, sir. Can you please continue the session?
All right. So coming back to the session, am I audible now, ma'am?
Yes, sir.
Okay. Thank you so much. So we were talking about artificial general intelligence, where it is actually the stage 2 part, where it's combined with a machine intelligence theory, which refers to a computer which is as smart as a human across the board, or it is actually as smart as a human, which is actually a theoretical concept, not really used much, against super intelligence, which is much smarter than the best human brains in practically every field. That actually is just a theoretical concept for now, which is machine consciousness. The work has been going on. It is the stage 3, the most advanced stage, also known as ASI, or artificial super intelligence. So I hope everyone is clear about what are the types of AI. Sorry for the disturbances in the between. So there was some distraction, so maybe I missed any point. So moving on to the next part, which is the machine learning fundamentals. Now, machine learning, it allows the systems to learn from the data without explicit programming. Accuracy will improve as the data exposure increases. Now, everyone, we all are working on these concepts. So I'm not going into much of the details about these concepts. Just a brief recap on how these concepts actually work. So, as I already told you, models become more accurate as they process more data. Just like I have taken one example from India, where ICICI Bank, they uses ML algorithms to detect unusual transaction behavior for fraud prevention. Now it has actually just an update that now every bank, almost every big bank, the big names in the banking industry, they are using these kinds of algorithms, these kinds of advanced algorithms, along with AI to detect fraud transactions, or the transactions if they are not matching with the common behavior of the consumer. In this regard, I would like to give my example. While traveling from metro, I actually travel a lot in the metro. So what happened is that I was required to transfer some money to a person which was not known to me or was not in my contact. But the request had came from a trusted source, so I was transferring it. So the bank was not allowing me or was stopping me because they had recognized that this could be a fraud or maybe a fraudulent or unusual transaction behavior for this particular customer. So I was receiving calls and they were monitoring it continuously, and I was receiving calls, and in the end I couldn't transfer that money, and next day I had to go to the bank and sort this things. So these kinds of ML or algorithms or transactional behavior for studying these kinds of cognitive behaviors, which are not usual for a particular customer. Now almost every bank has adopted these kinds of algorithms. So they are learning from the patterns from the historical data of the customers as well. So going on to the next part, this is a diagram. You can take a screenshot if you want. So these are the various fundamentals of machine learning. So it's a very huge and a very vast topic. So I'm not going into the much detail of this. So, but I have tried and covered all the parts of machine learning. There are basically three parts: unsupervised learning, supervised learning, and reinforcement learning. So, and students are also working on federated learning and things like that. So, these are the basically a gist of the machine learning fundamentals, where it shows the learning paradigm which supports different problem types. Moving on to a next domain, which is a very important domain, and as you might have seen in the earlier diagram, the key domain of AI, which is deep learning. Now, deep learning uses multi-layer neural networks. It is highly effective in vision, speech, and medical imaging, just like radiology platforms in Apollo hospitals for the medical image analysis. So these are basically used for computer vision projects or image processing projects, or you can combine these kinds of pattern recognition with computer vision. So many projects or many papers can be used and published on these concepts. So these are trending and a very I should say a very publishable trending topics which are into trend and into liked by everyone. So moving on to the next topic, which is the NLP part. Now NLP is getting very famous these days because the one advantage it has, it a machine, but it understands and generates human languages. It is critical for chatbots. Now chatbots are everywhere, right from the admissions. I am onto an educational institute, so we in the university also there are so many admission chatbots. In banks there are so many finance related. In companies which are small finance companies, they are using it for saving investments advices, and they are using these platforms which are automated and which saves a lot of time of the customers as well as the representatives of the bank as well. And it also supports multilingual systems. One example is Bhashini, which uses NLP heavily to translate content across major Indian languages. Computer vision, as you all are aware, it extracts meaning from images and videos. A wonderful example is traffic management systems, which use CV a lot. Now they are called as ITMS in Bengaluru, which also stands for Intelligent Traffic Management Systems. They use CV to detect violations and manage congestion. Delhi also uses some kinds of computer vision based traffic systems. Many other big cities also, they are adopting these kinds of AI related and surveillance and retail analytics and healthcare imaging automation. So it's almost everywhere used by these sectors. Now the next one is the foundation models of AI. So basically, what are foundation models? So foundation models are large pre-trained models that generalize across tasks. They form the backbone of modern agentic AI. So we are slowly and moving towards the agentic AI part. So these are the basic foundation models. As you can see, if you can see my cursor. So these are traditional ML models, and here they are the foundation models of AI. Now, what is the role of data in AI systems? Now, data, if I want to answer this question in one line, so data is the fuel of AI. Quality and diversity of data directly impacts trust and accuracy. They are, like for example, data.gov.in is a treasure of data sets from where you can take a lot of data sets, government data, verified data sets, which support AI applications in weather forecasting, public health and agriculture. Say for example, you want to write a paper on healthcare and cybersecurity, as you might have understood that cybersecurity is one of my research areas. So if I want to write a topic or a paper or do a project on this, then you can use these verified and reliable data sets which are on data.gov.in, which is a government-backed data set site. So data is basically the foundational resource or is the fuel of AI, which enables the AI models to learn patterns and make predictions. Now, one concept, one word is used a lot in AI, which is algorithms. Now, what are algorithms? Algorithms are just the logic which is used by AI models. It's a step-by-step logic which is used by AI models, and they define how data is processed and how decisions are made using AI. AI is only good as its algorithmic logic. So this is a gist about the algorithms. Now, few concepts which are used in AI a lot, which is training versus inference. So in short, training is where learning happens, and inference is where AI is actually used in real-time systems. So one example of this is startups like Niramai. They deploy trained AI models for breast cancer screening at hospitals. So now training teaches the models using data, while inference is when the trained model makes prediction in real time. So I hope the difference is because they are interrelated topics. So this is necessary when you study about AI or agentic AIs, what these small or little concepts are. Next is supervised learning. Now supervised learnings, it relies on labeled data. If you give it raw data without the labels, the reliability decreases, and supervised learning is totally dependent and relies on the labeled data. It's effective but expensive due to the labeling effort. So traffic violation detection in Hyderabad trains models using labeled images of road violations. On the large scale, this is used, but on a smaller scale, generally the supervised learning part is sometimes omitted. Now, if you can see the diagram here, supervised machine learning is trained using labeled data. Now, this is the raw data here. Then it's labeled. If you can see the examples, they are all elephants and camel and cows and animals like this. So now they are being labeled as cow, elephant and camel. Then they are fed to the algorithm. Then they are processed, and then the output is it has categorized every animal according to its labels. So this is a small example of supervised learning. Next is unsupervised learning, which is the most common ones, which is this kind of learning finds hidden patterns in unlabeled data. Now, due to this unlabeling or not using the labels, unsupervised learning is a bit less expensive. So It is very powerful for clustering and segmentation. If you can see the diagram here, this is unsupervised learning. Taking the same example, we are feeding this raw data where we have not labeled what kind of animal this is. And now it will interpret unknown output. No training data set is there. Then it will move through few algorithms. Then it will process it, and it will give the output of the hidden patterns if there are any, and it will give the output without the labels. Now this is unsupervised learning, where the raw data is given and then it categorized according to its the processing or the algorithm which is being used in this. Next part is RL, the reinforcement learnings. This learning trains agents using rewards and penalties. Now this is the foundation of agentic AI. If we can see the example here, this is the raw data fed in an environment and agent, and this is the output where it differentiates the various patterns and the various colors. There are like squares, the small squares, the stars, the pink stars, the orange ones, and the blue ones, or so these kinds of things are being done on reinforcement learning, also known as RL. Now we are on to the main topic, which is known as agentic AI. Now with these support of these concepts, you might have understood what actually AI is all about and how agentic AI. And now we will be moving on to this agentic AI. So what is actually an agentic AI? Yes, agentic AI is a shift from passive tools to autonomous systems. They can plan, they can act, they can evaluate, and they can adapt as well. Now if you can see this diagram, here we have given a small depiction what agentic AI is all about. So it does a autonomy part, it does adaptive learning, it understands the language, the workflow is optimized, and it can also use multi-agent and system conversation also. Now this diagram also shows these kinds of, so agentic AI works end to end. Now what are the characteristics of agentic AI? The key traits include autonomy, planning, environment awareness, and self-improvement. What is the need for agentic AI? Modern systems require AI that does not wait for prompts but acts intelligently. The systems which can think, plan, and act independently rather than waiting for user prompts. It reduces the human workload, it improves the efficiency, and enables automation at larger scale. An example could be smart agriculture platform, which uses semi-autonomous AI agents to recommend irrigation, fertilizer, and other kinds of decisions to the farmers for making good decisions on what kind of crop they should use, what kind of irrigation systems they should use, what kind of fertilizers, and so on. If there are benefits, then there are challenges as well. So the biggest challenges are safety, bias, predictability, and ethics. Agents may make decisions which are unintended, obviously, due to biased data or unclear instructions from the user. So Indian fintech company, they face challenges in ensuring AI-driven loan approval systems to remain fair and unbiased. So the data, if it's not fed properly or it is biased already, the historical data, if it's biased, then it will surely affect and impact the decisions of agentic AI. Now these are the various challenges which we face in agentic AI: data sprawl, inconsistent quality, complex compliance with agencies, slow decision making, industry bottlenecks, And what can be the solutions for this? So it can be automated using data governance. The real-time analytics can be processed. More compliance can be improved. Automated checks on the compliance part can be done. Decision making can be enhanced by using real-time analytics and strategic planning. And industry applications like telecom, healthcare, finance, retail, they leverage agentic AIs. So the bottlenecks are decreased a bit when you are using these kinds of industry applications. Now, what is the architecture of these kinds of systems? So AI systems consist of pipelines for data, models, inference, and deployment. And what is the knowledge representation of AI? Knowledge representation is how information is structured so machines can reason and draw conclusions. Like AI systems in Indian legal tech startups, they map case laws using knowledge graphs for faster legal research. Reasoning and decision making and AI. So AI uses logical inferences. Decision making is the heart of agentic behavior, choosing what to do next. Just like Niti Aayog also use these kinds of AI tools which assist in data-backed policy reasoning and public governance. What are the search algorithms in AI? Search algorithms help AI explore solution spaces efficiently. Now, what is planning in agentic AI? These are various features and these are various points which are related to agentic AI. Planning breaks goals into achievable steps, which enables the autonomy. If you can see this diagram, this is the planning part of agentic AI. Decomposition first and interleaved. So these are a bit technical topics to be discussed in this. So this is the planning part of agentic AI. So these are breaking the goals into achievable steps and so that the AI systems can be more autonomous. What is the perception in AI systems? Perception allows agents to understand the real world inputs. Just like CCTV networks in Delhi, they interpret crowd movement for real-time monitoring. Now, a newer concept of multimodal AI, which combines text, vision, and audio for richer understanding, has also came up. Like Vaisa, a startup, they use multimodal AI to combine the text and emotion cues in mental health. It enables more human-like interaction and decision-making in agentic systems. Talking about human-AI interaction, so effective interaction ensures AI adoption in classrooms and institutions. There are few ethical considerations in AI also. They can face issues of bias, transparency, privacy, and trust in AI systems. This diagram depicts what are the ethical considerations in AI. It integrates legal and ethical dimensions of AI. Now, there are few risks also in agentic AI deployment. Autonomous agents may make unpredictable or unsafe decisions if not properly aligned with the human goals. So, the challenge is to ensure proper instructions from the users, supervision by a human, and safety mechanism is crucial. Just like testing of autonomous drones in Indian agriculture require strict monitoring by the agencies to avoid unintended field damage. So one of the risks of deploying agentic AI is I'm trying to describe here. So what is the machine perception in agentic AI? Perception is the foundation of autonomous behavior. It enables AI agents to interpret sensory inputs like images, audio, or text to understand their surroundings. The various learning paradigms which are supporting the agents. Now, agentic AI depends on reinforcement and continual learning. This is the paradigm which actually is supported by the agentic AI behavior. It relies on RL, self-supervision and continual learning to improve autonomously. Just like IIT Kanpur, it uses reinforcement learning models, RL models, to train autonomous drones for dynamic obstacle navigation. And in the previous slide, as discussed, they are also used for smart agricultural purposes as well. Now, little bit about memory and state tracking. So memory enables long-term context and multi-step reasoning in AI agents. Conversational AI deployed by Indian banks, they retain customer history for better service recommendations. Multi-agent systems, when one agent is not able, or maybe if the environment is shared, so there will be multiple AI agents will be working together or competing actually. It enhances the scalability of the project and allows distributed problem solving. In major e-commerce companies, this kind of multi-agent systems are used heavily. One example could be Flipkart, which use these kinds of multi-cooperating robots for sorting and retrieval of the items in their warehouses, and they automate this process instead of using a workforce which is more faster, more efficient sometimes, and it's continuously monitored by us humans as well. Now these are the multi-agent systems. There are single systems which we are seeing in these slides. Now multi-agent systems are also here, just like these kinds of multi-agent systems, as you can see on your screen as well. Now we have talked about autonomy. Now what is actually autonomy in agentic AI? The autonomy levels is the higher autonomy would be requiring stronger governance. It can range from lower autonomy to higher autonomy, where assistance can be on the lower part and self-governance is on the higher part. So it helps in determining the required level of human supervision and system accountability. Metro train trials in Delhi use mid-level autonomy, which is requiring partial human oversight. So these kinds of autonomy levels are there in agentic AI. What is the cognitive structure of AI agents? Now this defines how agents think, how they plan, and how they act. What are the various tools and frameworks for building AI agents? Startups, they use LangChain style frameworks to build agents for automating customer service workflows. There are many other frameworks which you can use, API integration frameworks, reasoning engines, memory modules, and there are so many frameworks and tools for building AI agents. They actually simplify building autonomous task performing AI systems. ChatGPT has also introduced agentic AIs, and Gemini has also used, now they are using, Perplexity is using agentic AI. So every major AI platforms, they are moving on to this latest concept of agent systems, whether it's a single agent system or a multi-agent system. So these are the various list of, you can take a screenshot of these tools, and you can also try and build up a agentic AI or agents of AI. Mostly they are open source and few of them are paid, and these are the various voice agents. The more advanced that you move forward in building these, you can start with a basic AI agent with little bit of voice support, and that so just a textual support for doing the work, and then move forward as we progress towards the advanced part of AI agents. Now how agentic AI can be useful. So I have just taken few case studies which so you'll quickly see how AI can be used in education. So AI agents can personalize learning and assist the faculty. In healthcare, agentic AI reduces the clinician workload and improve diagnostics. In governance, agentic AI improves citizen service delivery. For personalized learning, learning adapts dynamically to student behavior. And the various examples I have taken from India only, like CBSE is for AI-driven education. They are piloting this kind of evaluation for long-form student answers. Autonomous assessment. It enables scalable and unbiased assessment. You can see this diagram here where it is being used in AI-driven education. It's a very large-scale project of the government where they will be using these kinds of assessment platforms and frameworks. Another one is multi-agent support for teachers, where agents can assist the faculty with planning and analytics. Another one can be higher education systems, HEIs, where legacy systems will remain a major barrier, but just a minute. But institutions are adopting these kinds of suites, which are where they have integrated these kinds of AI systems in higher education systems also. Now, RL, as I told you, this is the base of agentic intelligence, which enables self-directed decision making. These are the core functional capabilities of intelligent agents. Agents, they can sense, they can decide, they can act, and they can improve as well. This is a simple core component of AI agent. They can perceive, they have knowledge base and memory, they can reason and make decisions, they have a learning mechanism, they can act and they can execute as well. Now, a few limitations of traditional AI versus agentic AI. If I want to say this in one line, so traditional AI is reactive, agentic AI is proactive. So this sentence summarizes what traditional AI can do and what agentic AI systems can do. Now there are various opportunities for agentic AI in national digital platforms. Agentic AI can optimize national scale systems just like UPI, fraud detection and anomaly spotting by National Payments Commission of India, and NPCI is also exploring agentic algorithms for these kinds of transactions as well. Now, humans and human oversight will always be a very important part, which is totally non-negotiable. So, human in the loop is non-negotiable in this. They are not here, the agentic systems are not here to replace the human parts, but they are just here to enhance, make it more safe, make it more fair, and make it more accountable. Now, whenever this kind of supervision is there, these kinds of features are ensured, and the clear policies are also needed to regulate high, especially in the case of high autonomy environments. Now, agentic AI in multimodal environments, where combining the inputs improve the autonomous reasoning, obviously. This is a simple visual where agentic AI working in multimodal environments. These are the various environments. We can see the cursor. enhanced data integration, the transformation of AI in technology, various AI insights, revolutionizing data analysis, diverse real world applications, and all right, so we were talking about adaptive decision making of agentic systems. Now agents can adapt to continuously, they can adapt continuously using the feedbacks. Reinforcement driven behavior on the other side also improves through iterative learning of agent training. The workflow can be automated in institutions. Institutions can benefit from autonomous agents. Human agent collaboration models is a newer concept in this, where TCS is using human AI collaboration frameworks in financial risk assessment workflows, which ensures a balanced control between the human expertise and the AI efficiency. This is the 5 stages of human AI collaboration. I was reading about it and then I saw this diagram, so I thought I would be sharing this with my fellow researchers as well, where AI can work as an assistant, it can work as a co-pilot, it can execute the modular tasks, and it can operate autonomously within systems, and AI will be fully replacing the roles. Some human roles may be replaced or work together in tandem with and collaborating on the work which they are doing. Now, agentic AI, there is a need for domain-specific agents, where specialized agents can perform best within scope. Obviously, continuous evaluation is essential for these kinds of work, where incorrect or biased decisions can impact the working of agentic AIs. So there are self-monitoring agents as well. Agents can also track their own performance, detect anomalies, and modify strategies. Infosys uses self-monitoring AI agents to optimize their cloud infrastructure performance for clients. This is a little bit about how an AI agent can self-monitor. And this, they can observe, they can plan, and then they can act on this. For resource optimization, smart grids in Kerala, they uses AI agents to real-time load management and power distribution. Then ethical governance of agentic AI. Ethics, they build trust and adoption. So Ministry of Electronics and IT, MeitY, they promote ethical AI guidelines for deploying agentic systems in public services. Now, distributed coordination among AI agents. Agents collaborate at a scale, and ISRO uses distributed AI systems for coordinating the satellite data processing across multiple ground stations. This is a small diagram which depicts how multi-agent system architecture works along with the collaboration strategy. For smart mobility, AI can be also used as they can optimize the urban mobility like traffic signals, optimize the routes, the vehicle coordination, as we already discussed about the ITMS or the traffic management system in Bangalore. They uses AI-driven agents for adaptive signal control. A very great feature like conversational agents. So AI tutors is a buzzword today, which support personalized education. One of my favorite fields, cyber defense. CERTIN collaborates with AI startups to deploy agent-based security monitoring systems. Real-time learning in autonomous agents. Agents adapt continuously. Another diagram which shows how autonomous AI agents work. These are the four main pillars of how real-time learning is done by autonomous agents. Now, trustworthy agentic AI systems, MITI funds research on explainable AI to improve transparency in autonomous decision systems. Institutions obviously must ensure that the AI agent should behave reliably and transparently during the tasks which are autonomous or which requires a little bit of autonomy on the parts of agentic AI systems. Healthcare diagnostics are very sensitive part, but they are here to assist the clinicians. As I already told you, Apollo hospitals, they use AI agents for early screening of cardiac and cancer risk. There is a concept of multi-agent negotiation where agents resolve the conflicts autonomously among themselves. Just like example is Indian Railways, they deploys automated negotiation algorithms for optimizing the freight scheduling. These are the negotiation systems, a small diagram to depict how agent 1 and agent 2, they are negotiating themselves and resolving the conflicts if there are any. For agricultural intelligence, I already told you, precision agriculture, they benefits from agents. Public service delivery, another very good concept where Aple Sarkar program of Maharashtra. This portal uses AI-driven agents for citizen grievance redressal so that the citizens can reach efficiently and more closely to the government, and they can resolve their grievances if there are any with the government. For monitoring, continuous surveillance can be done with minimal human input. Just like Hyderabad Smart City Command Center, it uses AI agents for autonomous CCTV monitoring and anomaly alerts. For financial decision support, HDFC Bank employs AI agents for credit risk scoring and automated loan, and also they enhance fraud detection. For disaster management, one of the most efficient and most useful feature is AI-assisted coordination tools. There are various tools which can integrate weather, GPS and sensor data to guide emergency operations. Just like NDMA, the National Disaster Management Authority, they are also using these kinds of coordination tools for disaster management. This is a small diagram. I have taken it and just for depicting how a coordination can be done in disaster management as well. Adaptive user modeling, as the name suggests, agents are personalized with the human interactions. Byju's AI engine, they learn the behavior or to personalize practice sessions of the students. For predictive maintenance, agents, they can forecast failures early. For retail optimization, they can optimize the supply chains. For query handling, agents can respond and act across systems. So this is a small diagram where you can see how the query can be handled by various autonomous agents. Spatial intelligence in agentic AI, one of the startups of Gray Orange Robotics, they use spatial intelligence AI agents for autonomous warehouse navigation. Now, when we are coming to the end of this session, let's see what is the future of agentic AI in India. Obviously, it's very bright. One great mission run by the government is the National AI Mission, which promotes large-scale agentic solutions for public sector transformations. So, in the end, as educators, we must adopt AI responsibly and ethically. It's our responsibility to understand these technologies deeply, adopt them ethically, and guide their integration into real-world applications. This was just a brief on how to understand the concept of agentic AIs. Now, agentic AI in itself is a very technical and a very complex jargon-based technologies. So I was just touching upon the various concepts of agentic AI so that you can have a basic understanding of how agentic AI works in this. Obviously, they are redefining on how AI is helping India to build intelligent systems which are enabling the automation. Just give me one moment. So, before signing off, as we come to the end of today's session, just let me summarize the key message in a very simple way. Artificial intelligence, especially agentic AI, is not just another technology trend. It represents a shift from the tools that respond to systems that can plan, that can decide and act. However, autonomy without responsibility is a risk. That's why human oversight, ethics, and governance must always remain central. For educators and researchers, the opportunity is not to compete with AI, but to use it very intelligently to reduce routine workload, improve the analysis, and focus more on thinking, mentoring, and innovation. I encourage you all to reflect to one question after today. Where can AI assist you meaningfully without compromising the academic integrity? So with these words, thank you so much for your time, for your attention and participation this evening. I wish you all the very best in your teaching and research journey. Have a very pleasant evening, and these are my contact details once again. So if you want to contact me or keep in touch with me, or let's have a connection on LinkedIn as well. So these you can take a screenshot or you can click a picture. In whatever way, you can always contact me on my email address. And if you like my session or you whatever feedback what you want to give, you can always send me, and I will try and best to improve on your valuable suggestions as well. So with these words, once again, the very best in your teaching and research journey. Have a pleasant evening, and thank you once again for your time. And I really look forward to hearing from you all. So, thank you so much, organizers, for giving me this wonderful opportunity. So, with these words, I would like to end this session. Sanjana? Yes, Ashwin. Yes, sir. You were saying something.
Hello?
Yes, ma'am. I'm here.
Okay, I'm extremely sorry, sir. Unfortunately, there is some issue, so that's why I disconnected. I tried to connect with the other device, but I don't know, something like some network issue.
It's all right. It's all right, ma'am. It happens, ma'am. It happens with everyone.
Okay, sir.
It's all good, ma'am. Yeah.
Thank you so much, sir, for your appreciating, and this lesson was so amazing, and I love to be a part of this lesson, sir, and we all are very grateful towards to you. And thank you so much, sir, for today's section. And today's section we are going to end here. Every participant, those who are participant, thank you so much for your precious time, and thank you so much, Mohit sir, for your precious time as well.
Thank you so much, madam.
Thank you, and I would like to request everyone, please kindly leave. Thank you so much. Once again, we'll see you in the same time. Thank you. Participants, I would like to request tomorrow we'll join on the same time, which is assigned it. And today's section is over. Please kindly leave. Thank you.